Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss about least recently used page replacement algorithm with an example. So I request everyone to watch the complete video for better understanding. Look at the reference string 476 176 127 26127, meaning is that CPU is trying to access the page number 4, then page number 7, then page number 6, so on. The main memory is logically divided into frames. For your understanding, I have considered the three frames such as frame 1, frame 2, frame 3. Now if you have three frames, we can insert three pages only at max because the size of a page will be equal to the size of a frame. So single page you can insert in a single frame of a main memory. Now let's assume that CPU is trying to access the page number 4. If it is available in the main memory, then we will say that it is a page hit. If it is not available, then we'll call it as a page fault. Now let's take that page number 4, page number 7, page number 6 is available in the main memory. Now CPU is trying to access the page number 1. Whether page number 1 is there in the main memory? Not there. Because 476 is there, page number 1 is not available, then we'll call it as a page fault. To execute the instruction, we need to insert the page number 1 into the main memory. Already the main memory is full. Then what we have to do? We have to remove one of the existing page. Then we have to insert the page number 1. Now which page we have to remove or which page we have to do the swap out? It depends on the replacement algorithm. If you are using first in first out page replacement algorithm, the page which was inserted first will be removed first. If it is a optimal page replacement algorithm, the page which will not be used in future for longest duration, that page we will remove and we will insert the page number 1. When it comes to the least recently used page replacement algorithm, page will be replaced which is least recently used. We will look at the past references. Okay, when it comes to the optimal, we will look at the future references, but when it comes to the LRU, we will look at the past reference. Which page was not used for long duration, we will remove that one. Okay, I hope you have understood the theory. If you still have any doubts, don't worry, I will discuss this LRU algorithm with the given example. Look at the page number 4. Whether page number 4 is available in the main memory? Currently all the frames are empty, meaning is that no pages are available in the main memory, and CPU is trying to access the page number 4 which is not available. If it is not available, we will say that it is a page fault, and then we will insert the page number 4 in the any one of the frame. Let's take that in frame number 1 it is inserted. Now CPU is trying to access the page number 7. Whether page number 7 is there in the main memory? Not there. Again it is a page fault. Okay, so we will insert the or we will do the swap in, meaning is that bringing the page from the secondary memory and keeping into the main memory is called swap in. Now CPU is accessing the page number 6, it is not there. Again it is a page fault. Then again we have to do the swap in. Page number 6 we are doing the swap in. Now look at the pages which are available in the main memory. Page 4, page 7, page 6. So main memory is full. Now CPU is trying to access the page number 1. Is it available? Not available. So it is a page fault. Now we need to swap in the page number 1. Already the main memory is full. So how can we do the swap in? We need to find a victim page and then we have to do the swap out. Meaning is that you have to remove any of the page, whether 4, 7, 6. It depends on the replacement algorithm. Now LRU. In LRU what they are saying, page will be replaced which is least recently used. Look at the existing pages 4, 7, 6. When this page number 4 is accessed here, 7 here, 6 here. So which was least recently used? Page number 4. So you have to swap out the page number 4 and you have to swap in the page number 1. So currently page number 1, page number 7, page number 6 is available in the main memory. Now CPU is trying to access the page number 7. Whether page number 7 is available? Yes. If it is available, we'll say that page hit. Now CPU is trying to access the page number 6. It is available in the main memory. Okay. See, page hit is occurred, so there is no need of swap out and swap in. The same pages will be available. So again 6 is a page hit, so there no need to swap out and swap in. So same pages 176 available in the main memory. Look at the page number 1. Yes, it is also available. Again it is a page hit. So 176. Now look at the page number 2. Page number 2 is available in the main memory. It is not available. So it is a page fault. So now what you need to do, you have to swap out any one of the existing page. Then you have to swap in the page number 2. Which one you have to swap out? That depends on the algorithm. We are using the least recently used algorithm. So you need to look at 1 is referred here, 7 is referred here, 6 is referred here. Am I right? Because why I am looking 176? Currently we have page number 1, page number 7 and page number 6. So we need to look at 1 when it referred here, 6 here, 7 here. So which one was least recently used or least recently referred? This one. So 7 you have to swap out and 2, page number 2 you need to swap in. So after swapping the page number 2, the main memory consists of page number 1, page number 2 and page number 6. Now we get the CPU is trying to access the page number 7. So again it is not available, which is a page fault. So if it is not available, we have to remove one of the pages. Look at the page number 1. It is referred here. Page number 2 is referred here. Page number 6 is referred here. Which one was least recently referred or least recently used? Page number 6. That you have to swap out and you have to swap in the page number 7. So currently you have the page number 1, page number 2, page number 7. Now CPU is trying to access the page number 2, which is available in the main memory. So it is a page hit. So we no need to do the swap out and swap in. The same pages will be available in the main memory. Now CPU is accessing the page number 6. Whether page number 6 is available in the main memory? Not available. So it is a page fault. If it is a page fault, we have to swap out one of the existing page. Which one we have to do? Look at the reference. 2 is referred here, 7 is referred here, 1 is referred here. Are you able to understand? So which one was referred least? Least recently used is 1. So we have to swap out the page number 1 and we have to swap in the page number 6. So currently we have page number 6 to 7 in the main memory. Now CPU is trying to access the page number 1. Just now we have swapped out. So it is not available. Again it is a page fault. If it is a page fault, what we need to do? We have to find the victim page and we have to, as the main memory is also full, so we need to find the which page is least recently used. 6 here, 2 here, 7 here. So 7 you need to swap out and you have to swap in the page number 1. So you have 6 to 1 are the pages which are currently available in the main memory. Now CPU is trying to access the page number 2 which is available. So it is a page hit. Okay, sorry for it. It is a page hit. So we no need to do any page swap out and swap in. Now 7 is available. It is not available. It is a page fault. So as it is a page fault, we need to execute the instruction, that not we, CPU has to execute the instruction, then we have to insert into the main memory. Okay, so already the main memory is full, so we need to remove or swap out any one of the page. Which one we have to swap? We need to look at the references. Now past references. So 1 is referred here, 2 is referred here, 6 is referred here. So 6 is the least recently referred. So you have to remove the 6 or you have to swap out the page number 6 and swap in the page number 7. So you have the page number 7, page number 2, page number 1 in the main memory. Is it clear? Are you able to understand? So we need to find the number of page faults. Okay, are you able to understand? So the number of page faults are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 phase faults are there. Is it clear? Because each phase fault I have represented with the cross symbol, and page hit I have represented using the tick symbol. So 1, 2, 3, 4, 5, 6, 7, 8, 9 page faults are there. Number of page hits, you count the number of tick marks. 1, 2, 3, 4, 5. 5 hits. Now we need to find the hit ratio. Hit ratio is equal to number of page hits by total references, which is 9 plus 5 into 100. If someone asks you to compute the miss ratio, then or the fault ratio, you have to compute the number of faults by total reference, which is 9 plus 5, which is 14 into 100. Okay, even sometimes they will ask you what are the pages currently available in the main memory. Then you have to say page number 7, page number 2, page number 1. I hope it is clear for you. If you still have any doubts, feel free to ask me in the comment section. For practice, what you have to do is that take a same string, okay, in same reference string. Instead of 3 frames, you make it into 4 frames. Then you find the number of phase faults, number of phase hits, hit ratio and fault ratio. Please write it in the comment section. If it is correct, I will appreciate you. If you have done any mistake, I will correct you. Thank you for watching the complete video. Have a nice day.